Hello everyone, I hope you're all staying safe. This is Andrian and Faye. We're here to discuss about the quadratic function, experiencing A, B, and C, our week 6 discussion board topic. We were asked to come up with observations. We started off as number 1, when both variable B and C are 0, the variable A starts off as a straight line before bending in the middle, going up to form a U shape. As the gap between both sides of the U shape widens, it moves fast compared to when the gap gets narrower. It moves slow. When both variable b and z are 0, the vertex of variable a, the vertex meaning the x value found in the quadratic function, remains at 0 when the graph moves. When both variable a and c are 0, the variable b has two sides, the right side and the left side of the line. As the left side of the line rises, the right side falls and vice versa. When both variable a and c are 0, the left and right side of the line of variable b is perpendicular to the vertical axis. Both lines move fast as it moves away from the vertical axis, but then slows down as it approaches the vertical axis again. Number 5, when both variable a and b are 0, variable c is represented by a straight line that moves up and down the vertical axis without bending, and the vertex remains as its original value. When both variable a and b are 0, the straight line that represents variable c moves as a constant speed. We were also asked to make assumptions or hypotheses, and we came up with these three ones. Number 1, does variable a only determines the shape of the parabola? Number 2, does the variable b only determine the position of the graph if we were to choose to graph for a linear function? Number 3, does the speed of a moment of any graph have a significant meaning in terms of making a quadratic formula? Furthermore, if a equals 0, the line on the graph does not bend. In short, we are just graphing a linear function, since the value of a technically means that we are trying to graph a quadratic function. As a reminder, when graphing quadratic functions, a should not be equal to 0.
Hello everyone, my name is Faye and I'm here to walk you through the solutions for A through G. So our central issue is that we have collected data on the number of people infected with COVID-19 and we're just solving different aspects of it throughout A through G. So before we dive into it, I just wanted to go over the different values of A, B, and C on the quadratic formula, and I know we did that in the observations, but I think seeing it graphically also helps. So A pretty much determines how quickly something opens up or down the parabola, and B affects the way it crosses the parabola on the y-axis, as you can see there. And then C is the y-intercept. It just affects its position. So if we've set C to 6, it's just going to be right there. So now that we got that cleared up, we can start. So for A and B, we are trying to ensure that at 3 days there are 100 people infected. So when we first plug in 3 on the x-axis table, imagine this says something else. When we plug in 3, the value appears to be 29.1, which is smaller than what we want. So from there, we just increase the value of C until we get to around 100. And the closest you can get is 100.1 before it starts skyrocketing. And from there, you just plug in the value of 3 in x, and you put in 100 on the other side, and you just do PEMDAS and you get 70.9, which is close enough to 71, not quite, but as you know, we're not supposed to get the exact value. So now the solutions for C and D. So now we're trying to completely make the virus disappear after 30 days. Wouldn't that be so nice if the virus could just go away in 30 days? But that's not going to happen. So when putting 30 on the x-axis, the value appears to be 120. Imagine this says 120. So that is a lot bigger than what we want. So now we're going to decrease the value of A, and we had to decrease it around here, and we just added a bunch of 3s until we saw that it got to a kind of perfect value of 0.03, which is the closest value to 0. And to solve this by using substitution, you just plug in 30 for x, and you put 0 on the other side, and you do PEMDAS, and you get to negative 0.1333. So now the solutions for E and F. So at this point, we're trying to make the number of infections reaches its highest point of 250. Now it doesn't signify the days, but me and my partner, we just decided to put 30 on the x-axis because that's kind of the value that we've been dealing with. And from there, when we put 30, the value appeared to be negative 60, which is a lot lower than we want. So as you can see, it's kind of the pattern of when it's lower, you increase it, when it's higher, so and so. So by moving the slider to 10.3, it would reach 249. If it was 10.34, it would be 250.2, but we just kept it at 249. And then to solve for substitution, you just plug in 30 for x and you put 250 on the other side, PEMDAS, and you get 10.34. As you can see here, when we put 30, it was 249 and at 10.3. So now the solution for G. So at this point, we're at time 0. There are 30 people infected. The maximum number of infections is 300, and all the infections are gone after 45 days. That's what we want everything to be read as. Not exactly, but that's just the problem that we're trying to solve. So here, x is equal to the number of days and y is equal to the number of infections. So if A is too big, it will drop down too fast, and it also plays a factor in how quickly it opens up. And B cannot be negative because that would indicate that there are a negative number of infections, which is impossible. And C is automatically 30. And remember, we also need the value of 45 to equal 0. So after a lot of tweaking and messing with it, we see that we had to decrease A to around this value to even get it close to 30. If we were to decrease it any more, then 45 wouldn't be 0 anymore. And I know that isn't a perfect 30 value, but the 45 was close enough. So we got the 300 to a maximum of 302, 35 to 45, and from there we got 45 to equal 0.03. And that is the solution for G. And I hope that all makes sense to you guys. Thank you so much for tuning in and watching, and I hope you guys all have a safe and blessed year. Bye!
Now let's try to solve H. And honestly, this is the hardest part, and it's really a challenge for me personally. Okay, so for letter H, we have to come up with an algebraic way to solve the constants in part G, which are the values for A, B, and C. If variable x represents the number of days and y represents the number of infections. The problem gave us some clues on how we can solve the value of the constants. One is that it was stated when x is 0, there are 30 people infected, and this value is our vertical intercept of 0, 30. And as we know that the vertical intercept gives us the value of c, so our c is equal to 30. It was also stated that after 45 days, there are 0 infections, which is our horizontal intercept of 45 and 0. We have to consider this point too on the graph. It was also stated that the maximum number of infection is 300, but we don't know when, so it's question mark 300. We need to find the value of x. Okay, so now let's start by just using the point 45, 0. Okay, the quadratic function y equals ax squared plus bx plus c. And then we just have to substitute 45 and 0. So 0 equals a times 45 squared plus b times 45 plus 30. And now we have the first equation. 0 equals 2025a plus 45b plus 30. Okay, we can't do much with this function since we have two unknown values, the value of a and b. Okay, now a recap. The vertex is the maximum point in the parabola, and it represents the x value on the parabola. The vertex is also represented by the formula x equals negative b over 2a. Furthermore, we need to consider another point given in H, which is the question mark 300. Okay, so the formula for the vertex gives us the value of x. We can just plug that and replace it for the question mark. So we have the value of x equals negative b over 2a and y equals 300. As you can see, I wrote it down and then just placed the picture in it. So using the quadratic formula again, we just have to plug in the value of x and y, and then we can come up with the final equation at the bottom on the box is 300 equals b squared over 4a minus b squared over 2a plus 30. Okay, we needed two different equations to solve for h. The first equation we came up, a slide before this, is 0 equals 2025a plus 45b plus c. And now the second equation is 300 equals b squared over 4a minus b squared over 2a plus 30. Okay, so now we have two equations. And those two equations we need to plug in on the on the Desmos website. Okay, so if x is equal to, a, y is equal to b, we just have to plug in the given equations a while ago. So 0 equals 2025x plus 45y plus 30. And it's represented by the picture on the graph as the red line. And the second equation is 300 equals y squared over 4x minus y squared over 2x plus 30. So it's represented by the blue line. The challenge for h is that to come up with an algebraic way to solve for the constants in part g. As you can see here, these functions intersect at the point negative 0.563 and 24.649. So now we have the values of a, b, and c, where a is equal to negative 0.563, the value of b is 24.649, and our vertical intercept value for c is 30. Okay, there's two possible points that we can come up with. The point negative 0.00039 and negative 0.6491. It fits the criteria. Let's say where at time 0 there are 30 infected. Yep, it's included. And when after 45 days there are 0 infections, and it also fits the criteria. And the maximum infected people are 300. Yep, it does. This point right here fits all the criteria given. But if you look at the x value when y is 300 on the graph right here, the value of x is negative 832. This doesn't make sense since we can't have a negative 832 days.